because X increase a lot. So under the same mg means that is less, less stiffer. If X is very small, like in the shock absorber of the car shock absorber, the spring constant is very high. How much X, how much is the compression of the spring in a car? Very small, right? Means that the spring that they have are much stronger than this spring. You understand what I mean? So this is the spring constant. The unit, Newton per meter. Good. Additionally, the second thing that we need to know is how to get the acceleration. The force is negative kx. What will be acceleration? If the spring is moving like this, on a surface along x, imagine that I extend the spring. Let's say that this is the point of equilibrium when the spring is not extended. If I extended a distance here and I release, what will be the acceleration of this system? What will be the acceleration of this system if I release this? No more force. What is the only force that will be acting when I release? The force done by the spring, right? So that will be the only force. In which direction will be the force done by the spring here? On the object. In which direction will be the force done by the spring? To the left. So the force done by the spring will be the only force. So if I said the force done by the spring is negative kx, and I want to find the acceleration, because that's the only force, assuming that there is no friction, this will be equal to what? Ma, according to the Newton law. So what will be the acceleration of the spring at any time? Negative kx over n. What will be the magnitude of A? This is the vector. What will be the magnitude? Kx over n. When the acceleration will be maximum, at what position? When the position is less, x equals 0, or when it's maximum extended? At the maximum extension. So when you come here and the spring is at the maximum extension or maximum compression, you will have the greatest acceleration, which is basically when it's at rest. So when the object is at rest, remember, you go extended and this will move back and forth. Like here. This is along, imagine that this is along x. Imagine. Just to see, to not look at the gravity. So, this is the situation. At what point will be the greatest acceleration? At the lowest point or at the highest point? That will be the maximum acceleration. It's not moving at that point, but it will be moved. So the change in velocity between not moving and moving, that change in velocity gives the acceleration. Remember, the acceleration is not velocity over time. It's change in velocity over time, or the derivative of the velocity over dt. So the acceleration is greatest in magnitude at the end points. And that end point, maximum distance, will have a name that will be called amplitude. So this will be the minimum when the spring is completely compressed, negative A, and A will be called the amplitude in the simple harmonic motion. Amplitude, by definition, A capital, is the maximum distance or minimum. Maximum or minimum? Maximum distance. Distance doesn't have minimum. Maximum. The maximum distance from the point of equilibrium. So what will be in this case the amplitude? This distance. From here to here is A. In this case, what will be the amplitude? Look, this is my point of equilibrium. This is my point of equilibrium. when you extend it from there, what you extended is what we call amplitude. It's not the distance from the normal length. It's the distance from when this reached the equilibrium point, this. Now, if you extend it, this distance that I am extending is my amplitude. And always will go to that point if there is no friction. Or if there is no loss of energy. It will go back and forth. So to the negative amplitude, to the amplitude passing through the point of equilibrium. This is the way that the spring works. So this is the amplitude. Any question on the acceleration? How will be, or how can we find the magnitude of the maximum acceleration? At what point did I say that is the maximum acceleration? At the maximum amplitude. At that x, how is called x? What was the letter that we assigned? Amplitude, a. So what will be my magnitude of the maximum acceleration? K, a over what? Over n. This is the maximum acceleration. Good. We know now what is the maximum acceleration. The next thing we need to know here will be so we know the force, we know the acceleration. The next thing we need to know here will be the energy. I will start with energy and then I will move to the motion of the spring, or the block spring system. Let's start with the energy. What will be the energy at any point? Energy of the block spring system, or energy of the oscillator in simple harmonic motion, block spring system, which is the general model of the, because all will follow the same rule, negative kx. So let's start with the block spring system. The energy. What is energy? Mechanical. What is mechanical energy by definition? The kinetic plus the potential. What is the kinetic energy?